how the directed acyclic graph controls create, update, and destroy. This is the part where Terraform stops feeling like a script runner and starts feeling like a planner. Terraform does not execute your files. Terraform executes a plan, and that plan is generated from a graph, a directed acyclic graph, a DAG. The DAG is built from relationships. Relationships come from references. If object B needs a value from object A, then B depends on A. Terraform turns those truths into edges in the graph. Only after the graph is known does Terraform decide actions. Think of the plan as a walk through a map that you did not draw by hand, but your code defined. Terraform walks the graph in an order that respects dependencies, not because the order is preferred, because the order is required. If a dependency is not met, the next step cannot be valid. When the plan contains creates, Terraform groups them into waves. Wave 1 contains everything with no unmet dependencies. When wave 1 becomes real, wave 2 becomes possible. This is why multiple resources can be created in parallel. Parallelism is not magic. It is just independent nodes in a graph. Here is an example of trying to create an auto-scaling group. In wave 1, the main must be created first for the VPC, then the security groups and subnet. Next, the launch template and then the load balancer. And then finally, the auto-scaling group. An update is not always a simple edit. Sometimes an attribute changes and nothing else depends on it. That is a local update. But sometimes the change value is an output that others consume. Then the update propagates. The DAG is how Terraform detects what must be revisited. Some changes force replacement, not because Terraform is strict, but because the provider API says, I cannot change this, I can only start over. Replacement means the old object must stop existing, and the new object must begin existing. That is destroy plus create. Terraform must place that replacement into the graph without breaking dependencies. This is where ordering becomes safety. For destroy, the direction flips. If D depends on A, then B must be destroyed before A. Terraform is not guessing here. It is following the same edges, just in reverse. Here is the example of trying to destroy the VPC main. To destroy it, we go in reverse order. First, the auto-scaling group is destroyed, then the launch template and load balancer, then the security group and subnet, and then finally, the VPC can be destroyed. Now the identity layer. The graph describes objects, but the state ties those objects to real identities. An object in configuration becomes a tracked identity in state. That identity is what allows Terraform to say, create this, update that, destroy that one. Without stable identity, there is no stable plan. Here is an example of an identity in the TF state. Here you see the identity block and the identity for the security group. Two risks to hold calmly. First, if dependencies are missing, Terraform may create in an order that is valid for the graph, but wrong for reality. This often happens when values are hard-coded instead of referenced. Second, replacement can cause downtime when the dependents cannot switch cleanly. The graph cannot guarantee zero interruption. It can only guarantee logical order. Terraform is not a list of steps. Terraform is a set of relationships that become a graph. The graph becomes a plan, and the plan becomes create, update, and destroy based on tracked identity. Your job is not to manually control order. Your job is to describe the truth.